Hi, my name is Adate to Ade, and the name of the organisms I'm gonna be talking about today is Staphylococcus aureus. Looking at this background, you can see how beautiful it looks. Looks like a grape. This is an image of a scanning electron microscope. Yeah, next slide. Morphology. Staphylococcus aureus, like I said earlier, is the name of the organism. It's spherical gram-positive bacteria, which is immobile and form grape-like clusters, like the picture on the right. Can you see how all the bacteria is like in cluster form? Okay, so colonies formed by S. aureus are yellow. Aureus is the Latin name for gold. Staph aureus and the genus Staphylococci are facultative anaerobes, meaning that it is capable of aerobic respiration in the presence of oxygen and in an anoxygenic environment, meaning that when there is no oxygen around, they can switch to fermentation. And as I said earlier on, it's a gram-positive bacteria. Now phylogeny. Okay, so when I look for phylogeny, this was what I could get, but I'm going to talk about the taxonomy. Okay, so for the domain, we have domain of the bacteria. We have bacteria. The domain is bacteria. Kingdom is Eubacteria. The phylum is Firmicutes. The class is Bacilli. Order is Bacillus. Family is Staphylococcaceae. Genus is Staphylococcus, and species, the name of the name of the organism is Staphylococcus aureus. On the left image, you can see that out of all the other strains of Staphylococci, aureus is one of it. If you look at the one on 98, the one that has D83355 and D83357 are both Staphylococcus aureus, strains of Staphylococcus aureus. Okay, now to the image on the right side. It's a gram-positive bacteria, like I said earlier on. So on the gram-positive, we have the cocci and the bacilli and all the other bacteria that are gram-positive. Under cocci, we have Staphylococcus and Streptococcus. And Streptococcus, we have the catalase. It's a catalase negative. Under that, we have the beta hemolytic, we have the gamma hemolytic, and we have the alpha hemolytic. And under all those ones, we have each bacteria that fits in each subgroup. Staphylococcus, it's a catalase positive. S. aureus is a coagulase positive under a catalase positive. It's okay. So we have two other ones that are coagulase negative: S. epidermis and S. saprophyticus. Now, the history. Staphylococcus was first identified in 1880 in Aberdeen, United Kingdom, by a surgeon named Sir Alexander Oxton. It was found in the pus from a surgical abscess in a knee joint. In 1884, Anton J. Rosenbach, a German surgeon, isolated two strains of Staphylococci, which he named for the pigmented appearance of their colonies. Staphylococcus aureus, as I said, aureus is the Latin name for gold, and Staphylococcus albus, which is now known as Staphylococcus epidermidis, albus meaning white in Latin. Ecological role. Staphylococcus aureus is among the most common hospital-acquired pathogens. It is a normal inhabitant of the skin and mucous membrane in the nose of a healthy human. S. aureus is infectious to both animals and humans and may only survive on dry skin. Now let's talk about MRSA. MRSA is a bacteria that is resistant to many antibiotics. Studies show that about 1 in 3, 33% people carry staph in the nose, and usually without any illness. So you can be really healthy and like you still have staphylococcus in your nose. It's a human flora. It's part of, without it, like it's one of the bacteria that live in us. 2 in 100 people carry MRSA. MRSA meaning methicillin resistant Staphylococcus aureus strain. 2 people in 100 people carry that. Strains of MRSA causing healthcare associated infections often are multiply resistance to other commonly used antimicrobial agents, including erythromycin, clindamycin, fluoroquinolones, and tetracycline, while strains causing community associated infections are often resistant only to beta-lactam agents and erythromycin. It can be resistant to fluoroquinolones. So looking at that picture on the right hand side, it's a pus. It's a image of a infected skin, and you can see how the pus is coming out from the infected part of the skin. And if anybody comes in contact with that, it can spread, like the person can get affected to get infection also. Now the metabolism, all of that is just biochemistry, but yeah, it uses the pentose cycle in carbohydrate breakdown and glycolysis and glucose metabolism. SRS. It is known to use the Entner-Dwodorf pathway, and lactate is the end product of anaerobic glucose metabolism, and acetate and CO2 are the products of aerobic growth conditions. So lactate is the end product when it ferments and when it does fermentation, when it doesn't use oxygen, and acetate and CO2 are what the product it gets when it does use oxygen. Interestingly, in iron deficient environment, S. aureus has been found to redirect its central metabolism to sequester nutrients, helping it to survive in hostile host environment. Cool effects, right? Now, biofilm. We learned about this in class, and we learned that biofilms are like communities of bacteria containing biofilms are communities of bacteria within an extracellular matrix. It is known that staphylococcal biofilms can escape immune recognition because of their chronic and indolent nature. Biofilms serve to be very useful for Staphylococcus in many ways, including development of antibiotic resistance and, as mentioned, to escape immune response. That is, now looking at this picture, we have like the way it grows, like the way the biofilm grows. Then the first stage is the attachment. It attaches itself to the host or like the organism. Then it grows. Then it disperses actively. Now, molecular biology, the spark protein, fun stuff, right? Now, the protein A, also known as spark protein, is the one looking at the image on the right side is the one in blue, and immunoglobulin is the one in green. Okay. S. aureus produces numerous molecules that can potentially promote immune evasion, including protein A, which is known as spark protein, and immunoglobulin binding protein present on the bacterial surface and freely secreted into the extracellular environment. The spark protein binds to the Fc region of the antibody and the Fab regions of the B cell receptor, processes that are known to block opsonophagocytosis and cause B cell death in vitro. Protein A, spark protein, helps in the beta phagocytic engulfment and acts as an immunological disguise. It disguises itself so you wouldn't know, so the immune system wouldn't know that it's in there. Okay, so it's a pathogen, It can either be commensal or parasitic. Pathogen meaning that it's a microorganism that is able to produce disease. Staphylococcus aureus is an example of potential pathogens that lives in a commensal or parasitic relationship without producing disease. They do not cause disease in their host unless they have an opportunity brought on by some compromise or weaknesses in the host immunity. So you have to be like, your immune system has to be really good because they actually disguise themselves. So yeah. Why do we care? Not you can just contract. It's not the only way you can contract it is not just human to human communication or like yeah, you can't just contract. It's not just from human to human. You get it from your pets to the pets that are infected by S. aureus, that has the S. aureus infection. Resistance to most antibiotic, that's a problem because since it's resistant to a lot of antibiotics, you have to be careful because like if it mutates more, if they continue to mutate, because I feel like they mutate, and when they continue to mutate they become more resistant to more antibiotics. So if that continues, that will be a problem because we might actually run out of antibiotics to cure the infections gotten from the organism. And methicillin resistant Staphylococcus aureus causes pneumonia, bloodstream infections, which can be severe and if not treated can lead to death. To prevent this, you have to be as clean as possible using disinfectants, sanitizers, and detergents. So yeah, so as not to get the disease, you have to be extremely clean. Wash your hands all the time. Use, like I said, use detergent because it kills the bacteria and stuff like that. But yeah, and that will be it. Thanks for listening.